This is the 2020 to 2020 NAT 1 mark. So the weight percentage of copper in chalcopyrite. So we have to just calculate the weight percentage of copper. So in chalcopyrite, it is given Cu FeS2. So first we have to calculate the weight of the chalcopyrite. So it will be 63.55 plus Fe is given 55.85 plus 2 into 32.07. So it will be 183.54. So the weight percentage of copper will be weight of copper, that is 63.55 divided by total weight 183.54 into 100. It will be 34.62%. Next, the general formula for amphibole mineral it is given. It is the general formula A0 to 1 B2 C5 T O2 OH whole 2. So we have to find out the amount of octahedral aluminum in amphibole composition, this much. So the general formula of amphibole, it is, you can say W0 to 1, that is sodium, then X2 Y5, this is X, this place Mg will be 5, then Z8 O22 OH. So Z8, it is tetrahedral site, it can accumulate both silicon and aluminum. So that's why aluminum here is distributed here in Mg octahedral site and Si tetrahedral site. So this tetrahedral site, that means this Z, it should be 8. So here Z is only here 6.2. So what more we required? 8 minus 6.2 be 1.8. So that means 1.8 fraction of aluminum it is present in tetrahedral site. So you can write down the formula like this: Na 0.6 Ca 2 Mg 3.8 aluminum. It is given 3. It will be 1.2 here. Okay. So it will be add up to 5 according to the general formula. Then Si will be 6.2 and aluminum will be here 1.8. Then your O22 OH whole 2. So this will be the formula. So this fraction of aluminum is present towards the tetrahedral side, sorry, octahedral side, and this present towards the tetrahedral side. So here we have asked what will be the octahedral aluminum. So it will be 1.2. So this type of question you have to solve with the general formula. So how much octahedral sites are filled and how much aluminum will be required for both aluminum tetrahedral site and octahedral site, because aluminum can occupy both tetrahedral and octahedral site. Then if 3 to 6 is the Miller index of the crystal phase, so Miller index is given 3 to 6. Then the value of X in the corresponding Weiss parameter of same phase XA, YB, ZC. So if you have Miller indices, then we can calculate the Weiss parameter. It is the reciprocal of Miller indices. 1 by 3, 1 by 2, 1 by 6 we can take. So we can take the LCM 6, or we can multiply 6 in each fraction. 6 into 1 by 3, 6 into 1 by 2, 6 into 1 by 6. So it will be 3, sorry, it will be 2, 2, 3, 1, 2, 3, 1. So the X place will be 2. The value of Miller-Wabash indices, we have 4 bar 1 H naught. So in Miller-Wabash indices, it is a special type of indices which is only applicable in case of hexagonal system. So in case of hexagonal system, we use HKI naught. So there are 4 indices here. So that's why it is called the Miller-Wabash. other case we have only same Miller indices. So here the speciality h plus k plus I should be equal to 0. So if you have 4 bar, that is minus 4 plus 1 plus h, it should be 0. That means h will be here, h will be, so h will be 3 here, answer will be 3. We come to next question, the retardation of an uniaxial negative mineral of thickness. So thickness it is given 0.03 mm, and retardation it is given, del it is given 5160 nm. If the refractive index of the corresponding E ray, so E ray, that is epsilon it is given 1.486. So the value of refractive index of the O ray, so you have to calculate the omega. So it is a uniaxial negative mineral. So in case of uniaxial negative mineral, omega greater than epsilon. So we have to put the retardation formula. Retardation equal to thickness into birefringence. Your birefringence will be higher minus lower, omega minus epsilon. So retardation it is given 5160 nanometer. Thickness it is given 0.03 mm. So omega we have to find out. Epsilon we have to, it is given 1.486. So it will be 5160 nm divided by 0.03 mm. So here either you have to convert the nm into mm or mm into nm. Will be equal to omega minus 1.486. First we will solve this. So here your 5160 nm and 0.03 mm will be 30,000 nm. So it will be 0.172 equal to omega minus 1.480. Omega will be 1.652. So answer you have to give up to 3 decimals, so it is 1.652.